Hello, I hope everyone of you is fine. So last time we talked of doing the land use land cover change, so that we aim at doing the change detection maps for the year 2019 and 2023. And since we were required to do the change detections for a specified period of time, that's 2019 and 2023, was in essence as finding the okay, I'm using this project for someone to also make a tutorial on the same. So essentially, you can ask yourself, why am I doing for 2019 to 2023? That's because I done the biomass change for the year 2019 and 2023. And among the first objective was to overlook at the factors influencing biomass variation and what are these factors that could influence biomass. And one of the issues was to get the land use land cover change for the year 2019-2023. So for the first case, we had 2019, 2020, 2021, and 2022 and 2023. So last time I made a video for how to get the how to do the land use land cover change for each of the years. So I can just give a preview of what the maps look like before we embarked on the change detection as our main topic of the day. So for 2019, we had that is 2019. Of course, the values represented the value and the color represented the actual land use land cover for that specific year. So you can see the water sources, the forest, shrubs, grassland, pearlands, and hilltop. We had 2020, and that is how the same map was as at 2020. We had for the year 2021, that's it. We had for the year 2022, and you can overlook at the changes, the trend, and then we had for the year 2019. So essentially what I can show you is 2023 and 2019. So we had that 2023, that's it, 2019. That's 2019, 2023. So I want us to use 2023 and 2019 and 2020. Right. You can see that that's on 2023. That's how the map look like. You can see that we have some quite changes in the map. Maybe the shrubs and the grasslands are increasing over there, and also the water bodies. So I want us to do the change detection for the 2 years. So I'll just be giving a guidelines on how to do it because I have done the same. So the first case is that make sure you're having the two images for 2020 and 2023 so that we can have a look at the this small duration with the result that has taken place. Remember, in terms of getting the land use land cover, getting to understand about the adverse effects of climate change, we have to analyze images of up to 30 to 35 years for you to get a clear, consistent changes. So, but because we are dealing with the recent images, that's a Sentinel-2 image, and due to our specified time period, we can just have to overlook at the changes as it is, as just as a demo to you also. So when you want to get a change detection of any other images, this is the same procedure, simplified one. Now, so the first case, you load 2023 and 2023 and 2019. 2020 and 2023. So I have the two images at 2020 and 2023. So the first case is that make sure that the two images are in correct projection. So the first case, you can just come to data management tools. Let me remove this. So what you do is that click on the Act Toolbox, go to data management tools, projections and transformations, and then you can project your raster. So when you project your raster, you just choose the raster file that you want to project. So for my case, I did project 2020 and 2023. So you'll do the same for 2020 and 2023. What follows is that we now want to change the raster to polygon. So on the same toolbox, you click, then you come to conversion. So this is the option of conversion tools. So you'll be converting from raster to polygon. So we'll just click that. Then so you are converting the land use land cover for 2020 and 2023 to polygon. So after doing that, you'll convert the two images and then you click OK. So there is nothing that you'll be changing. You just click that. If you want to change the output location, you can do that and edit the name. That's okay with you, and then you can just click OK. So after doing that, this is the polygon that I did. I can just open for you one. Let me uncheck the two images, 2020 and 2023. So after doing that, you'll have this. You can open the attribute table. So initially, this is what will be displayed for the two polygon features. So after doing that, what follows next? So the first thing is you make sure that they are in correct projection, so that you won't be doing the projection and transformation. So you do the raster to polygon conversion. Then what follows is that on your geoprocessing tool up here on the menu bar, click geoprocessing tool. We do dissolve. So we dissolve. So what you do is that you choose the 2019. This is the 2019 polygon file. Then you click on the create code. This way you check. Leave alone the shape length and the shape area and the ID, object ID, leave alone that. Just use the create code. Then you click OK. Then on the same also, come dissolve, choose input feature as 2023 polygon file, choose create code. Then you do OK. But because I done the same, I won't be able to do the repetition. What follows next is we have to see what will be intersecting, which features and which features are going to be intersecting. So come to the processing tool, do the intersection. Okay, before then, maybe we can have a look at the dissolve. So you'll get the dissolve images. So you can open the attribute table, then add two new classes. As initially, you won't be able to see these two new classes. What you'll just get is the area, shape length, create code, shape, and the object ID. So click on this menu bar, then you add a field. On adding a field, you can input the class maybe underscore 2020, and then as an text, because those are the class values. Okay, and then this is what will be displayed. This is the class 2023. Then we also want to see the area, so we'll just add the area, and then area we can use either the depth or the float as an field property, and then you just click OK. Then how you'll just start your editor, and then you edit accordingly, because you'll be having your the create code. The create code are the actual values that you do and you are digitizing. So the first case, the first polygon will be representing the first value of your land use land cover, class 2023, right? And then on the area, you can do the field through the field calculator, the calculating the geometry. You can input your class values. So it will depend with the units that you want to do. Maybe in terms of kilometer square, the meter square, meter miles, depending on the country that you are interested in and the units they are using. So you can do the perimeter, the x coordinate centroid, y coordinate centroid. Then you also choose the projections. So you'll be using your projection that you did project your raster with. That will be displayed. Then you just click OK. So that is on the solving. Now, to get the intersection of the land use land cover, so that we can now add to change detection, you'll just on the menu bar, intersection tool. So what will be intersecting is the what you did dissolve. So it is 2020 dissolve, and then you come to 2023 dissolve also. So 2020 dissolve, this is it, and then 2023 dissolve, then you just click OK. So this will be displayed as this is what I did remain, but initially that is what will be displayed. Let me uncheck the 2019. So this will be displayed as the intersection. I just did I manipulated the name to change detection. So open the attribute table. So you'll be able to see that we have the dissolved, we have the grid code class 2020, then area of 2020, we have the raster dissolved of the first 2023, then we have the grid code, then we have the class 2023, and then we have the area, and then we have the shape length, and then the shape area. So what we will also add next is the chain detection as the class and the area. So you just come here, then you add the field, then you make the right change detection. Alright, then you just input on your text, then you enable your editor. You can click here. If it's not open, then you enable your editor. Then when it's active, you can start editing. Then you choose the what you want to edit. So for our case is the change detection. So just manipulate where your change detection is. Maybe we can also see it together. It's here. Then you make sure that you are checking the change detection that you want to edit. Then it's okay. Then you now edit. So if it's forest, you just input forest depending on your field. So you'll be able to even see what's that, what could be that. So initially this will be blank. Maybe I can delete this field. Let me stop the editing so that we do together that. Let me delete this field. Yes. I'll also delete this for the sake of editing each and every one of you. So I've said that you'll add a field. You can just write change detection. Make sure that you leave no space. Then you just input as text. Then okay. Then you can add another field as area change. This will be able to display the change detection per area of each and every class that we are doing. So we can input as dopo, then okay. So we'll be having change detection here. So you can just right click and then you come to field calculator, then okay, yes. So what will we are doing the change detection for the year 2020 and 2023. So we'll be using the class value field that we had added on when we did the solve. So it will be class 2020. Then we can put spaces and then add such right space, and then you are minusing to class of 2023 on the dissolve part. Then okay. So the records will be calculated automatically. Simple as that. And then on the area change, you can calculate the geometry, then you input yes, you see, so it will be in area. So I want it to be in kilometer square, then okay, then yes, so that will be displayed, right? So this is our map. This is the change detection now. So we can just input that. We can go to properties and then we toggle on what we want. So initially you'll be able to get it in form of features. So when you come to categories, then you input a chain detection if you want to analyze in terms of area. So that will be it will be in that manner initially. So what you do is that you change to the colors, you change to the color that you want. So for my case, Fairland, I'm representing with 40% of the gray, then Hilltop with the red, mass red, or the mass red, and then forest, of course, is the far green. Then we have the grassland, we can do this medium purple. Then you have the shrubs, can do with the solar yellow. Then you have the water sources, of course, that's on blue. Yeah, so you can see this is the change detection map. So what you do is that you can now make your map, then maybe you zoom out, zoom out the map, zoom out, zoom out, zoom out, still zoom out. Then you can use the panning so that you move your map right. This is perfect now. So you can write the title as change detection. Then you can also edit this so that you can edit this. Sorry, you left click, then you right click, then you can delete that, so that when you are having in form of the right, so this how your map is able to look like. Make sure you're having your scale bar, you have the coordinate system, you have the note arrow as here. So you can be able to see these are the change detection for the year 2020-2023. We can even have a look at how the area was at 2023. So that was on 2023, then this was on 2020. You can see, and then you can have a look at now the change detection after you also modernize the color change, right? So maybe let me uncheck so that you are able to serve that. So that is on 2020, 2023. So you can see 2020, 2023. Look at what is changing. So we had more of a grassland area in the okay, in 2023. Now so we can export this. You save your map, then you export the map. Maybe I can just show you how the map behaved, how it was as when we did export in form of JPEG and PDF. So you can appreciate how the map is very nice indeed, with the legend, with the scale bar, with the coordinate systems, with the note arrow, with the title. So everything is included, and it actually depicts. So the blue background was actually the Ewasongiro North River that is connecting to Lake Pogori and Lake Baringo. Then we have a hilltop, you can able to see here, we have here. So these are Pupal Springs, so it's a reserve. We don't expect too much of a residential or the hilltop or what. So we just expect majority to be shrubs and grassland and a bit of forest cover because of the few trees that are there. Right. Now, maybe the next thing is that we can visualize this on the Excel. So you just do that, then you can select everything. So select all, then you copy this, then you can input on your Excel, just paste that, then you can delete this all other field. You just remain with the change area change, and the change by class. So click this, delete, right? So what will be remaining is the object ID change, detection, and the area change, so that we can click on the pivotal, right? Then change detection, input to be rows, and then the change by area to be values. So you'll be able to analyze in terms of the areas that has changed over time. So you'll be having 2.75 of pearland has changed. Then we have the built up 0.1 forest and so on and so on. Right now, we can even do the visualizing form of chart. So you can do this. Maybe you don't want that, right? Maybe you can do this. Yeah, right. This okay. So what change in the area change that was at large is the grassland, and we have the forest, and okay, then we have the shrubs. Then of course what follows is forest, this, and then followed by the two, the water bodies and the water sources and pearland, I mean. So that's okay. Then you can just save the picture, right? You can just save the picture and also try to explain your results with this was your project. So what we uh, what we are actually doing is coming up with a map that was able to display the percentage by change, area change, the classes that has changed, and through visualization we are able to note, we are really able to note what has changed over time. So until next time, I think when we'll be doing the land use land cover using ArcGIS Pro or Google Earth Engine, or also the chain detection through Google Earth Engine or Python in other language or any other language, we'll be able to see the difference, which one will be the most correct method. Though this was the easiest, I do presume it's also correct because we started with Google Earth Engine doing the land use land cover. So suppose if any of you have a question, I'll just leave my email and my phone number, my WhatsApp number, and my associate links to various profiles, maybe on Fiverr and Upwork, LinkedIn, and GitHub, so that we keep exchanging ideas on what next topic I should be able to make and present to you. So until next time, goodbye.